Hello, the site that I chose is Saanich Transit Center by Commerce Circle and Glanford Avenue. I'll be looking into the ecological features and ecological design strategies for this site. I chose this site because I take transit weekly and I'm excited to see what they're building here. The Earth system I chose is geosphere, with some overlap with hydrosphere. The first dataset example is a borehole log for a parkway in Langford and is similar to one that would be produced for the Saanich Transit Center. It shows the soil layers down to 4.5 meters, the groundwater level, and how strong they are based on penetration tests. Borehole data like this is important because it confirms that the site is impervious with weak or saturated soils beneath the asphalt. The second dataset includes a map of catch basins and a map that indicates the watershed that receives the site's stormwater. The catch basin map shows where the storm drain inlets are around the site and can reveal how quickly runoff is captured. The drainage basin boundary map shows the site drains from stormwater systems into Colquitt's River. This map is important because it shows the ecological area affected by polluted, high-flow stormwater. This remediation dataset shows that part of the site has recorded history of contamination. That means pollutants like oils or metals could still be present and runoff has the potential to mobilize them, which makes ecological design even more important. Here you can see the cracked foundation and the impervious surface of the concrete and the puddle marks there. This is all signs that water was not filtrating that well. And that means that there was basically zero filtration and the water was just running along the concrete into the storm drains. As you can see here, there's drains here and then there's also a drain over there. Pretty much the water has no chance of being filtered by soil. So oils and contaminants just go straight into the drain and into ecosystems, which is terrible for the environment. See this site behind me? This site was listed as a remediation site, which means that environmental efforts were put in place to clean up the contaminants like oils and metals that were found on the foundation that ran into drains and into ecosystems. But just because they clean it up doesn't mean that there's not still contaminants left over. So that means ecological strategies must be put in place to ensure that there are no more contaminants and to ensure that environments are kept safe. See the site behind me? This was used for property restoration by Belfort, which means that there was probably contaminants and probably still are contaminants on this site. So due to that, it's probably a good idea to check out and see if there's any more contaminants and any site remediation that has to be done. When rain falls on undeveloped ground, water infiltrates into the soil. The geosphere slows down, filters out contaminants, and gradually recharges groundwater. A smaller portion becomes surface runoff because vegetation and soil absorb water along the way. On this site, the asphalt blocks infiltration, so rain can't be soaked or filtered. Instead, rain turns into surface runoff and quickly streams across the pavement straight into storm drains. This eliminates natural filtration and sends untreated water quickly downstream. Infiltration like these matter because soil filters pollutants and slows water before it reaches streams. When it's blocked, polluted runoff could harm downstream ecosystems. Ecological design strategies such as rain gardens, oil grit separators, and bioretention cells can help restore filtration and slow runoff on a site that doesn't allow proper infiltration. This in return can preserve life in wetlands and improve site resilience to flooding. This project requires geotechnical engineers to understand the soil and groundwater, environmental specialists to assess contamination and ecological risks, and civil engineers to design stormwater and ecological solutions. These experts make sure the site is rebuilt safely and protects downstream environments. This concludes my applied project on the new Saanich Transit Center.